Good evening, everyone. We are in the week 10 problem solving session of the NPTEL course, Basic Electrical Circuits. And week 10 is about first order circuits with time varying inputs. Let me share my screen. So, today's discussion is first order circuits with time varying inputs. So, instead of the DC input voltage, which we have considered in the previous week, we'll have some time varying input. So, for the timing, I'm considering a RC circuit for the ease of understanding. And input could be some value. So for the timing, we can consider it as V source of t, Vs of t, and this is my resistor, this is my capacitor. So I'm interested about this capacitor voltage Vc of t. So first of all, let us write the differential equation that we know. So I know that Vs of t is equals to Vr of t plus Vc of t. Okay. So then Vs of t is nothing but IR is what? It is IC, right? Current IC is flowing. So this is IC of t. So we have IC of t into R plus VC of t. So from this you can get Vs of t is equals to IC is what? C into dVCV by dt into R plus Vc of t. So this is the expression that we will be getting. So if I try to simplify it, or if I try to write in a better form, then I'll be getting something like this. RC into dVc by dt plus Vc of t is equals to Vs of t. So this is the expression that we have studied in the last week, and we are very much aware of this expression because we have been studying it for the past couple of weeks. So in the previous week, we have studied Vs of t is a constant. Then we have obtained Vc of t. So for the timing, let us assume Vs of t is some exponential. So let Vs of t is equals to some e to the power source s into t. So s is some constant. So now what we'll be getting is, in this case, we'll get Vc of t. It will have two solutions, right? So I'm generalizing the solution. You can write k1 into e to the power st plus k2 into e to the power minus t by tau. So we also know that tau is what? RC here. So this RC is coming from the natural response of the system, and the first term is coming from the, so we have two terms. One is coming from the input. So this is called forced response. So this is called forced response, and this is called natural response. Because because of the dynamics of the circuit, we have one term which will eventually decay out with respect to time. But this will stay because the input, it is dependent on the input. As long as the input is there, this will be there. So that's why this is a steady state term, and this is also transient term. So we can say that this is a steady state response. Steady state response, and this is transient response. So now, if you see this term, this will eventually decay out. Eventually, it will decay. And what happens? This will disappear at steady state because it will become zero at t tending to infinity. So steady state meaning t is tending to infinite. So at t tending to infinite, this term will eventually decay out, and we have only one response, which is k1 into e to the power st, which is the steady state response. because it is coming from the input. So that's why it is called forced response. If the input is not zero, then the capacitor voltage will decay out with the time constant tau, and that is coming naturally from the response. So that's why it is called natural response. So this is the basic idea. So for any given circuit, we'll have something like this. So if it is e to the power st, then we have input with some constant k1, and there will be some natural response term also. So now the question is, how do I calculate K1 and K2? How do I calculate K1 and K2? Yes, this is a question that we would like to ask. So now, how will I get K2? So first K2 is very easy. So let us start with K2. So for calculating K2, we have to use the initial condition. Because we know the initial condition, we'll substitute t equals to 0, and then we'll get K2. Plus some K1. In terms of K1 and K2, we'll get one equation. So maybe instead of writing K2, I'll write, we'll get two equations. So one is initial condition and the other expression. So now this is the solution of VC of t. So if we substitute this in this expression, we should get some term, right? Right. Because this should satisfy this expression. So say I'm calling this as the differential equation. Say this is the, I hope everyone is following. Are you following? No one is saying anything. Hello? Is everyone following? Yes, sir. Okay. So this is the differential equation. Now, because this is a solution, a generalized solution with some gains we have considered, because this is a solution, this should satisfy, right? So this should satisfy this equation. The solution should satisfy. Okay. So now what we are saying, so the solution will satisfy the differential equation. Okay. So now using these two equations, we have two equations, two unknowns, which means we can solve for K1 and K2. So here also we have generalized the solution. Say if the input is e to the power st. So basically the forced response will be a scaling factor of the input. So if the input is e to the power st, it will be some scale factor because it's a linear system. Because it's a linear system, you can say that the output and input characteristics are linearly dependent on each other. So we are getting the forced response, which is a linear multiplication or a scaled version of the input. And there will be a natural response, which we already know. It is e to the power minus t by tau, where tau is the time constant. So we can calculate the time constant and we can write. So first we have written the generalized solution. So now how to find the K1 and K2? For calculating the K1, we know that this forced response, I mean, this VC of t will satisfy that. And for calculating the K2, we know that initial condition. Individually, you will not get, you will get two equations, two unknowns. So in order to get those two equations, we have to use these two conditions. And then using this, we have to solve for K1 and K2. Similarly, if the input is, say, now here we have considered let Vs of t is e to the power st, right? So now I can consider let Vs of t is equals to some a cos omega t. So now what happens? Now it will be a scaled version of Vs of t. plus there will be some phase, because these are all filters, right? So there will be some phase delay with respect to input. So now the generalized solution will become something like this. So now the generalized solution will be Vc of t is equals to some k into cos omega t plus phi, because there will be some phase lag or phase lead which we don't know. We are generalizing it with some phi, plus say this is k1. Then we have k2 into e to the power minus t by tau. Again the same story. This will be forced response, natural response. So this is forced response coming because of the input, and this is natural response. Again, how will I find k1 and k2? The method remains same. Uh, so how do I find k1 and k2? Same. We need two equations because there are two unknowns. So if I take this up and if I add new page, or maybe I'll utilize this page only. So how do I? We have two equations, two unknowns. So the solution that we are supposed to get, it is satisfying the linear differential equation. So we'll substitute that, and another equation we'll get from the initial condition. So that is it. That's how we'll get. So is it clear? Maybe let me just quickly summarize. So in the previous week, we have considered that for any first order circuit, if the input is DC, we have discussed the solution. It will be something like this. Uh, Say any particular voltage, capacitor voltage, we can write Vc of t is equals to Vc of infinite plus Vc of 0 minus Vc of infinite into e to the power minus t by tau. Then individually we have calculated what is Vc0, what is Vc infinite, what is tau. Similarly for inductor current, IL of t can be written as IL of infinite plus IL of 0 minus IL of infinite into e to the power minus t by tau. Again individually we have calculated what is IL of 0, what is IL of infinite, and what is tau. So this is for the case where the input is DC. But because the input is time variant here, the term at the steady state will not be just a constant, but it will be a scaled version of the input itself. So first we have got the differential equation. Then we have seen that the input is, if it is e to the power st, then and the output will be scaled factor of e to the power st. So k1 into e to the power st plus some natural response, which we know it will be a scaled factor of e to the power minus t by tau. So now how will I find k1 and k2? We have to get two equations, which I will be getting from the initial condition. And the second equation I will be getting by substituting the solution in the differential equation, because it is a solution to that equation. It should satisfy. From this, we'll get two equations, two unknowns, and we can solve for k1 and k2. Similarly, if it is a cos or sine, because it is linear circuit and it's a low pass filter, the output will be a scaled version of the input, plus there will be some phase delay. So output will be k1 into cos omega t plus phi plus k2 into e to the power minus t by tau. One is forced response, one is natural response. Again, how will I find calculate k1 and k2? One equation from initial condition, one equation by substituting this solution in the differential equation, which will give us two equations, two unknowns, and we'll solve for k1 and k2. The same with sine omega t. Say the input is some d sine omega t, output will be k2 into sine omega t plus phi. It will be sine at the output with some phase difference, which we can calculate by substituting this in those equations. So now, how will we find k1 and k2? This we'll check by going into the problem solving session. So until this point, do you have any doubts, or is it clear? Hello? Any doubts, or is it clear? Clear, sir. Okay. Others? If you have any doubts, you ask. The today's week is very simple. You just have to uh, they are already given the solution. You just have to use these two conditions to find K1 and K2. So we'll solve few problems, then you will feel confident. Problem solving session. So someone has mentioned in the chat, sir, why natural response is always transient? Yes, very good question. See, the natural response, you can consider it something like this. So natural response is there, like you can consider this natural response when the input is zero. say the input is 0, e to the power st is 0, then we'll have Vc of t equal to k2 into e to the power minus t by tau. So now you can consider as a circuit where there is no input. So we have only resistor and capacitor connected in series. So now you can imagine something like this. Say initially there is some capacitor voltage. What will happen? It will decay through resistor, right? If the resistor is not there and say input is not connected and capacitor is kept open, it will stay at that voltage. But because there is a dissipation path, there is a dissipating element which will draw the current and dissipate it as heat. The resistor will draw all the power from the capacitor and it will get dissipated. So because there is no input in the circuit, there is no external source to deliver power to this circuit, whatever charge or the power that the capacitor is holding, it will be dissipated through the resistor. So that's why it will always be dissipating, which means with respect to time the capacitor voltage will become smaller and smaller and smaller until it becomes zero. So what happens to all the power initially that was there in the circuit, it will be dissipated as heat through the resistor because there is a resistor. So now if you see, if there is larger resistor, then tau will be large. If it is smaller resistor, tau will be small. So if you see, if it is larger time constant, it will take lot of time to dissipate. If it is smaller resistor, it will dissipate quickly because the time t is proportional to tau, right? If t is equals to 5 tau, then it is smaller value. If t is 7 tau, it is much smaller value. So if the tau is small, it will decay faster. If tau is large, it will decay smaller. I mean, it will decay slower. So that's why if there is no source in the circuit, the capacitor voltage is decaying. So that's why it is transient. Basically, it is the transient that is coming because of the initial condition. Say if there is no initial condition, then it will not come. So that's why it is always decaying. And that's why it is the transient response. Whereas if the input is steady, output should also be steady at steady state. And that's why it is a scale factor of the input and it is input dependent. Because as long as the input is there, the scaled version of the same will be observed at the output. Okay, so now let us start with question one. So if you see these questions are very, very simple. So they have given this, I'm sorry, I think this is assignment 9. We have to go to assignment 10. Yeah. So these questions are very, very simple. So they have given one circuit and they have also given the solution. So if you see, uh, one is forced response, one is natural response. So, okay, let me just take a snip out of this. So we have to determine V1, V2, and tau 1 and tau 2. So the questions are very, very simple once you understand the concept. Okay. So first, so this is our question one. Even though it has four subparts, we can consider this as a single question and we'll try to solve it. Okay. Okay. So this becomes our problem number one for today, and we'll try to solve it by understanding the concept. Okay, so they are asking here V naught of t. But first, let me calculate Vc of t. From there, I'll calculate V naught of t. Because whatever I have told, it is in terms of Vc of t, right? So let us not get into confusion, but I'll write something like this. I know Vc of t. So first, what I will do is, maybe I'll use A. So what I will do is first, let us calculate Vc of t. Okay. After calculating Vc of t, how will I calculate V naught of t? I know that Vc of Vs of t is equals to Vc of t plus V naught of t. So once I know Vc of t, Vs of t is already given and V naught of t is what? Vs of t minus Vc of t. So there is no confusion. Even if they ask some other voltage, first let us calculate the Vc of t and from there we can calculate V naught of t. Okay. So first let us write the differential equation which we said or which we have obtained for an RC circuit. Okay. Okay. So let us write this equation. So this is the differential equation. Agree. So now can someone tell me what will be the time constant for this circuit? What is the time constant tau? Anyone? 2 microseconds. Yes. So it is R into C. That implies tau is equals to 2 nano into 1 kilo, which is 2 microsecond. Very good. So tau is 2 microsecond. Okay. So we got tau. Now let us go back and see what we have learned. I have told that if Vs of t is equals to e to the power st, which is also similar. Here s is how much? Minus 1 by 1 micro. So if this is the case, then I know this is my output, right? So this is my output. Okay. So let us see. This is my output. So now I know Vc of t is nothing but k1 into e to the power st plus k2 into e to the power minus t by tau. So now can you tell me by substituting s and everything, what will be Vc of t? Because input is known. So first term will be k1 into what? K1 into e to the power. Okay. For making it much simpler, let me tell. From the question, we get s is equals to minus 1 by 1 micro, which is what is given. So what is s? S is some constant. So if you see, this is the input, right? Actually, I could make it more general and I could keep it k. I can add some k here, k into e to the power st, because anyway it is a scaling factor, right? Or instead of k, I can write a into e to the some constant a into e to the power st. So the same can be reflected here. So Vs of t is actually the input. So when you compare this and this, what you will get, s is equals to minus 1 by 1 micro, right? Agree? And a is equals to 2. But we are not interested in that as of now. But is that clear? S is some constant. And here it happens to be minus 1 by 1 micro. Okay. So now if I substitute S, I'll get K1 into e to the power minus t by 1 micro plus K2 into e to the power minus t by 2 micro. Agree how we are getting this expression? Or do you have any doubt? If you have any doubt, please ask at this point of time, because we are going to follow the same methodology for all the problems. So if you have any query, you can ask at this point of time only. Any queries or is it clear? Please respond. Question one, is it clear? Fagim, Hema, Kirtana, Priyanka. Sir, one more time. Okay. So if you see, I have told, yes, sir. Sir, e to the power st, sir. Yes. So basically, I am saying the input is some e to the power st. S is some constant here. I have considered S because sir has considered S, because why sir has considered, it is Vs, right? So that's why sir has considered S. So in order to clear the confusion, S is a constant. S is not the Laplace transform, that S. Here S is a constant. I have considered S because sir has considered the same. I want to use the same terminology. So if the input is some e to the power st, here it is e to the power minus t by 1, then Vc of t will be a scaled version of the input plus scaled version of e to the power minus t by tau. So maybe let me erase. Okay. So what is my Vc of t? Vc of t is a scaled version of the input exponential, which means k1 into input exponential is e to the power minus t by 1 micro, and scaled version of the natural response, which is minus t by tau is 2 micro. So now is it clear why we are getting that? This is the generalized solution that we have learned today, that this will be the solution for which we have to find k1 and k2. Okay, now it is clear. Okay. So now as I told, we are going to use initial condition and the solution will satisfy the differential equation. Okay. So now let us use the initial condition. First equation that we are going to get is initial condition. Okay. Let us see. So what they have given initial condition Vc of 0 minus is 1 volt. Okay. So Vc of 0 minus is equals to 1 volt. From our equation, can you tell me what is Vc of 0 minus? Anyone? What will be if t equals to 0? What will be the expression?
K1 plus K2.
K1 plus K2. Yes. So this will give us one equation. So from this I can write K1 plus K2 is equals to 1. So this will give me one equation. Okay. So this will give me one equation. And how will I get the other equation? Substitute the one equation is initial condition. Other equation is solution plus differential equation. So we are going to substitute this solution in the differential equation because it should satisfy. Okay. So let us substitute that and see. So now let me bring this solution. So this is the solution that we are going to substitute in this expression. Okay, let us see. So when you are substituting, you can substitute only the input. You can neglect or you need not substitute the natural response because natural response will anyway get cancelled. But if you are unsure, let us substitute the whole expression and see what will come. So RC is 2 micro as it is the time constant. So 2 micro into dVc by dt. So it is K1 into I'm just writing. You just check whether it is correct or wrong, and you also do it by yourself, which is very much important. Plus K2 into minus 1 by 2 micro into e to the power minus t by 2 micro. Okay. So this entire expression plus Vc of t, which is K1 into e to the power minus t by 1 micro plus K2 into e to the power minus t by 2 micro is equals to Vs of t. And Vs of t, how much did they give? That is the input. They are giving 2 into e to the power minus t by 1 micro. Okay. 2 into e to the power minus t by 1 micro. Do you agree until this point? Hello. I have written the expression. I will give you some time to check whether it is okay or not. I have just substituted that and RC is 2 micro because tau is 2 micro. I have substituted this and I have obtained this expression. So can you cross check and let me know whether this equation is correct or whether you are getting the same expression or not? Anyone?
Yes.
You're getting the same, right? Okay.
Yes.
Okay. So now let us simplify it. So I'll get minus 2k1 into e to the power minus t by 1 micro minus k2 into e to the power minus t by 2 micro plus k1 into e to the power minus t by 1 micro plus k2 into e to the power minus t by 2 micro is equals to my input, which is 2 into e to the power minus t by 1 micro. If you see, as I said, always this natural response will get cancelled because that's a generalized solution when there is no input. So it will always get cancelled because we are considering the input, which will happen only at the steady state because the natural response is not dependent on the input. It is the natural response of the system. So it is a equation of this when the input is zero. So that's why it will always get cancelled. And when there is some input, then this is the solution of the differential equation. So simply we can substitute this, but there is no harm in substituting the entire expression. So then you will know what exactly is happening here. So now from this, can you tell me what is the value of K1? What is the value of K1? Anyone?
Sir, minus.
Minus 2, right? And I know that K1 plus K2 is 1. So what is the value of K1? What is the value of K1? Sorry, K2, K2. How much?
3.
3. Yes, K2 is equals to 3. Yes. Now what happened? I got the solution of VC of t, right? So now let us write the VC of t. I know VC of t. So this is VC of t, and I know K1 equal to minus 2, K2 equals to 3. So here we got K1 is equals to minus 2, K2 is equals to 3. Okay. Yes. So now let us substitute it and see what we are getting. VC of t is equals to minus 2 into e to the power minus t by 1 micro plus 3 into e to the power minus t by 2 micro. But this is not what they are asking. They are asking V naught of t. And I have told that first let us calculate VEC of t, and from there we'll calculate what is the V naught of t. So Vs of t is this, and this is my Vs of t, right? So this is my V of t. So this is equal to this. Did you get what I was trying to do? So initially I got V naught of t, and from there I am getting the uh, V. First I got VC of t, and then I'm trying to get V naught of t because Vs plus Vc equal to V naught by applying KVL. So is this part clear? How I am trying to get V naught of t, or do you have any doubts? Hello, hello. Are you able to follow? So now V naught of t is nothing but Vs of t minus Vc of t. Yes, sir. Clear. So now can someone tell me what is the value of V naught of t? Huh? Anyone? You have to substitute this here and then simplify. So there will be two terms. One is e to the power minus t by 1 micro and another is e to the power minus t by 2 micro. Can you tell me what is the coefficient of this and coefficient of that? Okay. 4. Yeah, Roshan, you are right. So first coefficient will be 4. Next question will be minus 3. So 4 into e to the power minus t by 1 micro minus 3 into e to the power minus t by 2 micro. There is less than a minute. If this meeting ends, kindly join back. So now this is forced response, right? Because it's a scale factor of the input. So this is forced response and this is natural response. Because we have seen if it is scaled version of the input, that is forced response. If it is e to the power minus t by tau, then it is the natural response. There is less than a minute. Kindly note if this meeting ends, please join back. So now this is the solution that we got. Let us go and check. So this is the forced response. So V1 is 4 matching, tau 1 is 1 micro matching, and V2 is minus 3 matching, and tau 2 is 2 micro matching. So that's how we solve. I think this meeting will end. Kindly join back. Sir, can I write solution directly, sir? Any shortcut? Yeah. So Roshan was asking, sir, is there any shortcut? So this is the shortcut. We are directly writing the expression of the capacitor. And how will I know K1, K2? I cannot directly get K1 and K2, right? Until I check what is the K1 and K2 value. So how do I check? There are two conditions that we need to do. One is the initial condition. One is the solution that we substitute in the differential equation. So there is a shortcut to write the expression for the capacitor voltage, but there is a not a shortcut way to directly write including the gains, because how will I know the gains? They differ from circuit to circuit. If it is 1 nanofarad, again I have to calculate what are K1 and K2. And again, if it is some other input voltage, say e to the power minus t by some 4 micro, again, then I have to calculate what is the K1 and K2. So there is no shortcut to write including the gains, but there is shortcut to write with some generalized gains, which we need to find out by using these two conditions. So once I
Sir,
get VC of t, then I can calculate V naught of t. Yeah,
sir,
Bhuvan?
may I audible, sir?
Yes, yes. Now you're
Sir,
audible. I
can you
think there is some
explain
issue
about,
with. Uh-huh.
sir, can you explain about solving steps one more time, sir?
Yes, yes, yeah, definitely.
How to solve?
Yeah. So first here they have asked V naught of t, but I can directly solve V naught of t, but let us not get confused. So I have started from VC of t because we are very comfortable with VC of t. So here there is no harm in calculating VC of t and it will not waste our time also. So if we can calculate VC of t, then I can calculate V naught of t, which is Vs of t minus VC of t. So that's why I have started with VC of t because all the differential equations, everything is in terms of VC of t. So this makes our life simple and also there is no confusion. Now we know this is the differential equation for an RC circuit with input Vs of t, which we have obtained here. So I have directly copy pasted and I'm using this. So for this circuit, the time constant is obtained as tau equal to 2 microseconds. Okay. So now I got tau and previously I have told if it is e to the power s into t or e to the power some k constant into t, the Vc of t will be a scaled version of the input plus scaled version of the this decaying factor. Here the input is also decaying, so that's why we got it. But if it is input is e to the power t by 1 micro, then it will be e to the power t by 1 micro. So we have written the generalized solution for Vc of t for this input, which is scaled version of this exponential term plus scaled version of this decaying term that we are getting from the natural response, and tau is 2 microseconds. So now once we got this, how do I find K1 and K2? One condition is this Vc of 0 minus, which is the initial condition. I got one expression. Now, how will I get the other equation? Because this is a solution, it should satisfy this differential equation because it is the solution of this. So I have substituted that. Then I got value of K1 and K2. So once I got K1 and K2, I got the Vc of t. Once I got Vc of t, I can get V naught of t, which is Vs of t minus Vc of t. So now I got V naught of t, which is having two terms. One is the scaled version of the input, other one is the natural response. So in the question, if you see, they have not given what is tau 1 and tau 2. So now you have to understand which exponential term is corresponding to forced response, which exponential term is corresponding to natural response. So once you do that, I know this first term is forced response because it is a scaled version of the input. So now here V1 and tau 1 are what? 4 and 1 micro. So V1 is 4, tau 1 is 1 micro. They are asking in microsecond. And V2 and tau 2 are minus 3 and 2. So V2 is minus 3 and tau 2 is 2. So that's how we got it. So is that clear?
Yes, sir. Sir, what about the complex numbers? Sir, have used the complex
Sir has used the,
numbers, but it,
hello, hello, I cannot,
excuse me, sir.
uh,
Sir has used the complex numbers, but I didn't understand how he used it.
okay, okay, I'll come. Sir, can how to write the output equation directly? Yes. See, basically, output equation also will be in terms of this. So output equation V naught of t will be some scaled factor of e to the power minus t by 1 micro plus some scaled version of e to the power minus t by 2 micro. So which is what exactly we are getting. But again, it has two equations that we have to have, right? One is the initial condition. Say initial condition of Vs of t is what? 2, right? And initial condition of this is what? 1. So what is the initial condition of this? 1. Because if this is 2 at t equals to 0, if this is 2 and this is 1, this has to be 1, right? So the initial condition of this is also 1. If you substitute t equals to 0, you will get 1. So there is no harm in starting with V naught of t. But where will the trouble come? The trouble come with the differential equation because the differential equation that we have is in terms of Vc of t. Now we have to write the differential equation in terms of V naught of t. How will I do that? You can substitute Vc of t equal to Vs of t minus V naught of t in this differential equation. Then you will get everything in terms of Vs and V naught. Now you substitute that generalized V naught in this expression and then you will get another equation. But if you see, anyway, we are using this equation, right? So why would I take the pain to substitute this equation and then differentiate rather than I'll calculate Vc of t without any confusion and from there I'll calculate V naught of t. The V naught of t will also be the same. V naught of t equal to some b1 into e to the power minus t by 1 micro plus b2 into e to the power minus t by 2 micro. Now again you have to do the same initial condition and solution. substituting in the differential equation. But differential equation is not in terms of V naught of t. You have to first convert in terms of V naught of t and then substitute. Or I can directly calculate VC of t and then substitute in this. So both methods are equally correct. I am more comfortable with this because when I'm teaching you, you should not be confused. So that's why I have chosen this. It is very straightforward. Yes. Okay, better way is to find VC. Yeah, that's what I did. But I would suggest you to solve by using the other method where you use V naught of t. It may be a little bit tricky because there you are converting something in terms of V naught of t, which is like not a comfortable way for us because we are more habituated in terms of VC of t and IL of t. So that's why I always prefer to write everything in terms of inductor current or capacitor voltage because we are habituated uh, using that terminology throughout our life. So this becomes our problem too. So I hope there are no queries in the earlier problem, right? Is that first problem clear? Yes, sir. Yeah. So now I'll come to another interesting aspect. So here I have told that if Vs of t equal to A into e to the power st, then input will be a forced response of this plus some natural response, right? So let me just summarize here. Say this is Vs of t and this is Vc of t. Right. So now I am saying if Vs of t is some say a into e to the power some constant k into t, then output we are getting something like this k1 into e to the power kt plus k2 into e to the power minus t by tau. So this happens when the input is some k into t. So what happens when the input is something like this a into e to the power minus t by tau. So the input is something that is also similar to the natural response. Then you will not get directly like k1 into e to the power minus t by tau plus k2 into e to the power minus t by tau. If you actually substitute this equation or the expression in the differential equation and you if you solve, you will get something like this. What which is what they have given. So you will get something like this. So it will be k1 into t by tau into e to the power minus t by tau plus k2 into e to the power minus t by tau. So I'll map it and show. So if you see this expression, it is the same. But if you see that expression to this expression, it is not exactly same. You will not get a scaling factor when the input is this. So this is an exceptional case. So when the input is also a scaled version of the natural response, then you will get a different expression. You can actually solve it, solve the integration and do. But as sir has not covered that, I assume that solving a differential equation is not part of this course. So you can directly remember that when the input is a scaled version of the natural response, which is what is given in this question, then output will be slightly different as shown over here. So is that part clear? What I'm trying to say? Only this is an exceptional case. Yeah, clear. So now again, the process remains same. Only the generalized expression, there is an exceptional case, but the process remains same. Everything remains same. Okay, so let us just start. Uh, what do you know? Tau we know, right? So tau is also here 2 micro. Okay. So now I have written the generalized expression of VC of t. So again, we'll start with the generalized expression of VC of t. So we have VC of t is equals to some k1 into t by tau, which is 2 micro, plus k2 into e to the power minus t by 2 micro. So is it clear? Until this point, we have just substituted tau. and then we have take the common. So this is my expression of VC
Sir,
of
how
t.
did you get K1 into T by tau?
Sorry.
How did you get K1 into T by tau, sir?
Yes. So actually, sir, as sir has not explained, I'll explain you how you will be getting. So this is the differential equation, right? So because in this course, sir has not taught how to solve the differential equation. So I assume that this is out of the scope of this course syllabus. But if you want to solve, you can solve something like this. So basically, what is my input? The equation is something like this: dvc by dt plus vc of t is equals to e to the power minus t by rc. Right? Because input is e to the power minus t by rc. So now in this case, if you solve, you will get something similar to like what they have given. So basically, what you will be doing is you will be doing something like this. So say it is dvc by dt plus 1 by rc into vc of t is equals to 1 by rc into e to the power minus t by rc. So now let us do one thing. Let us multiply uh, on the both sides with e to the power t by rc on both RHS end and LHS side. So then I will get something like this: e to the power t by rc into dvc by dt plus 1 by rc e to the power t by rc into vc of t is equals to 1 by rc. Agree until this point? Hello? Whoever has
Yes,
asked, is it me? Okay. So now, because uh, I can write the LHS side something like this. I can write the LHS side d by dt of vc into e to the power t by rc plus, sorry, is equals to 1 by rc. Agreed?
yes, sir.
So now I can rewrite it something like this. So I'll write d of vc e to the power t by rc is equals to 1 by rc into dt. So now let us integrate it from time 0 equals to t, and this will be vc of 0 to vc of t. Okay. So now, is it clear until this point? So now I will get something like this: vc of t into e to the power t by rc plus some vc of 0 is equals to t by rc. Agree? Hello.
Yes, sir.
Yeah. Actually, to make it more generalized, maybe we can put a constant or gain a here. So we have a here because why it should be gain magnitude of 1, right? We have to make it more generalized. So let us make it some constant a. Then we have a into t by r. So now I can rewrite this expression something like this. So I will get, if you see, vc of t is equals to minus vc of 0 plus at by rc into e to the power minus t by rc. Or I can also write this as a generalized expression. Vc of t is equals to some constant k1 into t by tau plus some constant k2 into e to the power minus t by rc. So this is what we are getting if we solve. But sir has not covered this in the like theory part because I assume that that is not a part of the syllabus. But sir, we have skipped this part, and sir has told that this is the solution, which is exactly what we are getting. Forget about minus plus sign. We have generalized and put some constant k1 to k2. Clear? Whoever has asked, is it clear now?
Yes, sir.
Yeah. Okay. So now again the same. Once we get the VC of t, the only way that we know is initial condition, which is Vc of 0 minus equal to 1 volt, right? So now again, we will start with the initial condition and we will get the value. Initial condition. So initial condition they have given Vc of 0 minus is equals to 1 volt. So now if we substitute t equals to 0, can you tell me what we will be getting? 1. So K2 is equals to how much? 1. So this is the equation that we got. So now let us go back and see, I'm sorry, Vc of 0, they have given minus 1, not 1. I'm sorry. So this is minus 1, so K2 equal to minus 1. So Vc of 0 is minus 1 volt. So we got K2 is equals to 1 volt. Okay. So now initial condition is done. Now the second part is substitute solution in the differential equation. Or I'll directly write substituting solution. Okay. So this is the solution that we have. Let us copy it and paste it here so that we need not scroll up and down. And the equation, what is the equation? The equation is simple. This is the equation and RC is equals to 2 micro. Sir, K2 equals to minus 1. Yeah, yeah. K2 is my, oh, sorry. Yeah. Thanks for correcting. Again, I made the same mistake. Yeah. Thanks for correcting. K2 is equals to minus 1. Yeah. Thank you. So now we have to substitute this and we know that RC is equals to 2 micro. So yeah, substituting this and solving might be a little bit lengthy, but let us do it. That is the only way. So first we have 2 micro into, so differentiation of, you can consider this as U into V. So it will be U dV plus V du. So I am considering this quantity as U, this quantity as U. So first U into dV. So in the entire dVc by dt, we'll have K1 into P by 2 micro plus K2 into U dV is minus T by 2 micro into e to the power minus T by 2 micro plus V into du. So du is K1 by 2 micro into e to the power minus T by 2 micro plus Vc of t, which is K1 into T by 2 micro. I'm sorry. So here it is minus 1 by 2 micro because differentiation of e to the power minus T by 2 micro is e to the power minus 2 by 2 micro into minus 1 by 2 micro. So now Vc of t is this into K2 into e to the power minus T by 2 micro. And here we write the input. So now how much is my input? Input is 3 into e to the power minus T by 2 micro. 3 into e to the power minus T by 2 micro. So is this clear until this point? I have just substituted it. Now I'm going to solve it. Agree or any doubts you have? Clear or any doubts, further queries? Sir, how 3E? Because that is the input that they have given. So this Vs of t is already given as 3 into e to the power minus T by 2 micro. So this is given and this is Vs of t. Okay, sir. Yeah. So now let us simplify it. You also try to simplify by yourself. So if I make any mistake, you can uh, let me know. So first 2 micro, 2 micro, 2 micro will get cancelled. The rest I'm going to write now. So I'll get minus k1t by 2 micro into e to the power minus t by 2 micro minus k2 into e to the power minus t by 2 micro plus k1 into e to the power minus t by 2 micro plus k1t by 2 micro plus, sorry, into e to the power minus t by 2 micro plus k2 into e to the power minus t by 2 micro is equals to 3 into e to the power minus t by 2 micro. So now if I cancel this term is getting cancelled with this. So from here, this this is also cancelling with this. So how much we are getting? K1 equals to 3, right? Simple. And K2 also we got something like this. K2 is minus 1. Everyone agree? Hello. Yes, sir. Okay. So now I'll write VC of t. So from this, VC of t is K1t by 2 micro. So VC of t is K1t by 2 micro plus K2 into e to the power minus t by 2 micro. And Vs of t they have given us 3 into e to the power minus t by 2 micro. Again, if you see in this question, they are asking what is V naught of t. So again, V naught of t is what I know. V naught of t is Vs of t minus Vc of t. Right. So can you tell me what will be the expression of V naught of t? Anyone?
Sir, 4 into e power minus t by 2 micro minus 3t by 2 micro into e power minus t by 2 micro.
Yes, you are right. So this is the oral expression that I am going to get. So this is the V naught of t. So the process remains same, and we are also not thinking about the solution. The solution is also given. If you see these problems, they are already given the solution. So first you have to the same I have written in terms of VC of t. So the generalized solution remains same only for calculating K1 and K2. This is the proof. So initial condition and substituting the solution will give you both the equations, both the constants. Then I got VC of t. From there I have calculated B naught of t. So let us go and check whether the answer we got is right or wrong. So V1 is how much from the answer? 4, right? Right? V1. So V1 is this constant and V2 is the coefficient of t by tau. So tau is 2 micro. So what is V1? What is V2? Anyone? Someone has mentioned V1 is 4 minus 1.5. No, no. Maybe let me write this. So this entire thing is tau. So V1 is 4 and V2 is minus 3 because they have written V2 into T by tau. So please be careful. So V1 is 4 and V2 is minus 3. So let me just again summarize what we have discussed in this problem. So this problem is an exceptional case where the input is a scaled version of the natural response term. So in that case, the input will not be straightforward, but it will be in the way that I have shown here, which is k1 into t by tau into e to the power minus t by tau plus k2 into e to the power minus t by tau. So I have written the generalized expression for VC of t. Now I have given the proof, but we can skip if you want. Proof is just solving the differential equation, which is what I have done and I have shown. So now using this generalized expression of VC of t, we have two equations, two unknowns. And how will I get the two equations? one equation I can get from the initial condition, which is VC of t equals to 0, and they have given as -1, so I got K2 equal to -1. And the other one I'll get by substituting the solution in the differential equation, which I have done, and I have found K1. So both constants K1 and K2 I have obtained using these two equations. From there I'll get VC of t, and V naught of t is nothing but Vs of t minus VC of t. So from there you can calculate and get the expression for V naught of t, and it is also matching. So any doubts until this two questions we have discussed today? Two questions. So any doubt in these two questions? Anyone before we proceed further? Any questions? Is it clear? Whatever we have discussed till now, we have discussed two different problems. Even though circuit remains same, but they are two different types. One we have normal exponential, and the other we have the exponential, which is scaled version of the natural response. Yes, no doubt, sir. Solve one RL circuit. Yes. So now we'll move into a completely different question, which is RL question. And not only that, here the input is cos. So we are going to use what we have learned, and then we'll use that only. Also, they have given the output also. So before I move on to the expression, I would like to just show what we have learned. So I have told if the input is cos omega t, sum into constant, output will have one natural response e to the power minus t by tau and one forced response, which is k1 into cos omega t plus 5. Because it is a linear, the output will be cos, but a scaled version. And because it is acting like a filter, there will be some phase difference. Right? The input and output phase will not be different because it is acting like a low pass filter. So there will be some delay, or there could be some phase gain. So there will be some different phase, whether it could be positive or negative, it depends upon RC values and the input. But the generalized expression is something like this. So if you see the question, it is also the same. So they have written some scaled version of cos omega naught t plus phi naught plus v2 into e to the power minus t by tau. Okay. So uh, is that clear? The generalized solution, or do you have any doubts till this point? At least the generalized expression. Clear, right? Or any queries? Hello. Let me know if it is clear or if you have any doubts.
So no queries.
Yeah. Clear. Okay. Now if you see Vs of t is equals to 2 into cos 5 times 10 to the power 5t. So it is omega naught. So omega naught is equals to 5 into 10 to the power 5. Because it is a linear circuit, whatever the frequency that the input has, the same frequency output will also have. Because it will be scaled version of the input, right? So the scaling will happen in the magnitude, not in the frequency. So whatever the input frequency component, output will also have the same frequency component because it is linear. So only the scaling will be done, or there will be some phase difference. So input and output frequency will remain the same. So this is one aspect that you can remember. So input and output frequency will be same for linear circuits. Okay, got it. So now again the same. Here they have given V naught of t, but let us not start with V naught. We can start with IL because of the same reason, because we will get the differential equation in terms of IL and not V naught. So let us do the same thing. First, we have to get the differential equation, right? So Vs of t is equals to VL of t plus VR of t. So now Vs of t is equals to VL is what? L into DIL by dt plus R of t is what? IL of t into R. So from this I can get the differential equation, which is L by R DIL by dt plus IL of t is equals to Vs of t by R. So this is the differential equation, and we are going to substitute the generalized expression of IL in this expression. So clear until this point. From here we can also get tau, which is L by R. So for the given L and R, what can you tell me what is the value of tau? Anyone? What will be the value of tau? So tau is L by R. So for the given L and R, can you tell me what is the value of tau? Anyone? This is the expression of tau. So for the given question, what will be the value of tau?
2 micro.
2 micro. Yes. So L is 2 milli, R is 1 kilo. So it is 2 micro. Okay. Okay. So we got the differential equation. Now I will write the generalized expression of IL of t. So IL of t will be some scaled version of cos input. So it is omega naught t plus some phi plus k2 into e to the power minus t by 2 micro. Do you agree with this? And here omega naught is also given because it is the input frequency. Is this clear? The generalized solution of IL of t? Or do you have any doubts? No doubts. Okay. So now, first we'll start with the initial condition, which we are aware, k IL of 0 minus. So you can substitute IL of 0 minus is equals to 1. So now can you tell me what we will get by substituting K1? I mean t equals to 0. What will be the expression? K cos phi plus K2. Yes, you are right. So we will get K1 into cos phi plus K2 is equals to 1. This is one equation that we got. So now for the second equation, we have to substitute this in the differential equation, right? So that we can do. And substituting the solution. Okay. So this is the expression. Let us go and substitute this. Control C, Control V, and now this also. Control C, Control V. Okay, let us go and substitute. So L by R is 2 micro as we know. So 2 micro into dAL by dt. So minus K1 sine omega naught t plus phi into omega naught plus this is K2 into minus 1 by 2 micro into e to the power minus t by 2 micro. So this completes our first term, which is tau into dAL by dt plus IL of t, which is K1 cos omega naught t plus phi plus K2 into e to the power minus t by 2 micro. Now we are going to the input, which is Vs of t by R. So Vs of t is 2 cos omega naught t by R is 1 kilo. So we'll have 2 milli into cos omega naught. So here it is actually 1 milli. If you see, this is 1 milli. So here also we'll get 1 milli. So on the right hand side also now we are getting 2 milli. There is less than a minute if this meeting can kindly join back. So 2 milli into cos omega naught t. So here we have 2 milli into cos omega naught t. So let us just try to simplify. So omega naught is how much? 5 into 10 to the power 5. So 5 into 10 to the power 5 into 2 micro is how much? 1, right? So let me write omega naught is equals to 5 into 10 to the power 5. If you substitute that, you will get minus K1 sine omega naught t plus 5 minus K2 into e to the power minus t by 2 micro. This meeting might end. Please join back. Plus K1 cos omega naught t plus 5 plus K2 into e to the power minus t by 2 micro is equals to 2 milli cos omega naught t. If you see this, so if you see this will get cancelled with this. So the overall expression will be something like this: minus K1 sine omega naught t plus 5 plus K1 cos omega naught t plus 5 is equals to 2 milli cos omega naught into t. So now we are going to solve this expression. So how we are going to solve? So first of all, I can take K1 to be common. So I'll get something like this. K1 if I take common, I have cos omega naught t plus cos phi, right? So if I expand minus sin omega naught t sin phi. Then minus sin omega naught t plus phi, right? So sin omega naught t cos phi minus cos omega naught t cos phi. Agree or any confusion? Sorry, this will be sin phi. Cos omega naught t sin phi is equals to 2 milli cos omega naught t. Agree or any confusion? Please let me know if you have any confusion, because this is very critical to learn how to solve this type of problems. So if you have any query, please stop me at this point of time. I have just taken common and I have just expanded. Clear? Or do you have any query? Someone has mentioned. Clear. Okay. So now let us segregate cos omega naught terms and then sin omega naught terms. So first I'm segregating K1 into cos omega naught t. So if I segregate this, uh, cos omega naught t means this term and this term. So we have cos phi minus sin phi. Okay. Now I'll segregate the K1 sin omega naught t. So minus K1 sin omega naught t. So this term and this one. So we'll have sin phi plus cos phi is equals to 2 milli cos omega naught t. So we can directly compare cos omega naught t terms and sin omega naught t terms, because cos omega naught t will not change into sin omega naught t. So whatever is there, we'll have to compare with that. So I can directly compare cos omega naught t and I can directly compare sin omega naught t on LHS side and RHS side. So now I will be getting two equations. So you can compare LHS with RHS. Okay. So now we'll get two equations. First equation is K1 into cos phi minus sine phi is equals to 2 milli. And the second equation is minus k1 into sine phi plus cos phi is equals to 0. Agree? Any query until this point? Or is it clear? So this is very critical and you have to thoroughly understand. Sir, I could have compared without expanding. Yes, you could have compared without expanding. But if you see, we have sine omega naught t plus phi, cos omega naught t plus phi. But here you only cos omega naught t. I cannot compare this and this because cos omega naught t is different from cos omega naught t plus phi. I need cos omega naught t terms to be compared and sine omega naught t terms to be compared. So that's why I have expanded. Now it is cos omega naught t, cos omega naught t. So now I can compare. But omega naught t and omega naught t plus phi, how can I compare? Because they're different. So that's why I had to expand. Clear? Okay, sir. Yeah. So now if you see, uh, if I solve this term, sine phi plus cos phi is equals to 0, which means sine phi is equals to minus cos phi, which means tan phi equal to minus 1. So what is the value of phi? Anyone? What is the value of phi? Tan phi is minus 1. What is the value of phi?
minus pi by 4.
Minus pi by 4, which is minus 45 degrees. Okay. So now I got phi. So now whatever phi you got, substitute in this expression. So we have k1 into cos 40 minus 45 is 1 by root 2 and this is minus 1 by root 2 is equals to 2 milli. So what will be the value of k1? K1 will be 2 by root 2, 2 to cancel, root 2 times milli, right? Agree? Yes. Okay. So now let us go back and see there is one more expression that we got here. K1 cos phi plus K2 is equals to 1 milli. So now let us substitute this. So if I solve this, I'll get K1 cos phi. So K1 is root 2 milli into cos phi is 1 by root 2 plus K2 equal to 1 milli. What is the value of K2? Hello. What is the value of K2?
1 milli.
So
0, sir.
0. Yeah. K2 is 0. So now I got K1, I got K2, I got 5. So now I'll get IL. So what is the value of IL? The second term will vanish because K2 is 0. So what is the expression of IL that I'll be getting? I'll be getting IL of T is equals to K1, which is root 2 milli into cos omega naught is 5 into 10 to the power 5t plus 5 is minus 45 degrees. Is this clear? How we are getting IL of T? I have just substituted the values that I got. So I hope this should be clear. If you have any doubts, please let me know. Question are lengthy for one MCQ. Yes, I understand. I fully agree with this. But if you see, this is not one mark question. If you see, it has first part, second part, third part, fourth part. So it is 4 marks. So that's why it is lengthy. So these are the questions which are like passage. Once you solve the question entirely, you will get 4 marks at a time. So basically, this is a 4 marks question. And the second question is, I think, 1 mark and the 2 marks. And the first question is also 4 marks. So each question is almost 2 or 4 marks because if it has 4 variables, then you have to solve for 4 variables, 4 marks. If it is having 2 variables, then you have to solve for 2 variables, 2 marks. So it is not exactly 1 mark, but you will only get until you will not get marks unless you solve. So once you solve, you will get 4. You can, if you don't solve, you will not get 4. So it is very tricky situation because in order to get marks, you have to solve the entire problem. Even though you want to attempt one question, you have to solve all the four questions. So these are the questions where you will get either the full 4 marks or you'll lose the full 4 marks. So that's why you have to be very, very thorough with the calculations and very clear with the concepts. Okay, sir, it is not correct. Then zero. That is the problem. So that's why you have to be very, very careful with the calculations and you have to solve. So even I make mistakes. It's not that I'll not make. Even if I have solved before, I'll make mistakes. But in order to do that, I have to be very attentive, very focused on the calculations. And then also I have to solve more problems. Then I'll feel more confident because it is a human mistake and it's a human error that we make mistakes. Even I make mistakes. Even the professor make mistakes. But only we can improve by solving more and more problems. So when I was a student, in order to improve, I had solved many problems so that I make mistakes during my practice and I rectify them during the practice. Then I'll not make mistake in the exam. So we have to make solve more questions, make more mistakes, rectify more mistakes during your practice itself, so that in the exam you will not make mistakes. Else you will make the mistake in the exam. So now if you see, they are asking V naught of t. V naught of t is what? 1 kilo ohm into IL. So V naught of t is equals to 1 kilo ohm into IL. So if I calculate that, I'll be getting V naught of t is equals to root 2 volts into cos 5 into 10 to the power 5t minus 45 degrees. So this solves our entire problem. I'll also summarize what we have solved, but let us go check with the answers. So first they are asking what is V1. V1 is what? Root 2, 1.414. So it is 1.414. And what is the value of V2? 0, because this expression has vanished. So V2 is 0. What is the value of phi naught? What is the value of omega naught? Phi naught is minus 45. Omega naught is 5 into 10 to the power 5. So minus 45. This is 5 into 10 to the power 5, but they're asking kilo. So you have to divide by 10 to the power 3. So you will get 500. So it is also matching. So whatever we have solved, it is perfectly correct, no calculation mistake. But let me just go and just summarize before you ask your questions. So in this question, they have given input as cost. So output will be scaled version of cost with some phase. And one thing you have to keep in mind, the input and output frequency will not change because it's a linear circuit. So it will be scaled and it's acting like low pass filter. So phase will be shifted, but not the frequency. Okay. So first I have written the differential equation and I have written the generalized expression for the inductor current, which is IL of t equal to some k into cos plus k2 into the natural response term or the exponentially decaying term. I know again two conditions. One is initial condition. From there I got one expression and then substituting the solution. After substituting the solution, I got this expression. But here I have to expand it and then I have to compare the cos omega naught t terms on LHS, RHS and sin omega naught t on the LHS and RHS. Once I do that, I got 5. I have substituted this 5 in the first expression to get K1. Once I got K1 and 5, I have substituted in the earlier initial condition expression to get K2. Once I get K1, K2, and 5, I got IL of T. But they have asked V naught of T, which is 1 kilo ohm into IL. And then I got the expression for V naught of T. So basically, the problem I can just summarize in 3, 4 lines. So get the generalized expression for IL of T, get the initial condition, substitute the solution in the differential equation, then solve for all the coefficients or the gains K1, K2, and 5. So once you get IL of t, you can get V naught of t. So it is very simple, but only calculations are there. So the concept is pretty much straightforward and there is no confusion in the calculation. It can be done very simply. But only issue is calculations. And once you solve, you cannot answer any of these 4 questions. Sir, one request, please take one class at the end of last week for doubt clearing as many questions. I made mistakes in the current assignment. It would be very helpful. Thank you for pointing this out, Roshan. Actually, for every NPTEL course that I take problem solving sessions of, we usually take 12 problem solving session for 12 weeks. And at the end, after the problem solving session, I'll take one session, 1 hour session on doubt clearing session before you go to the exam. So we'll take 1 hour session. In that, if you want completely problem solving, I mean, any doubts, I'll not basically solve problems, I'll clear doubts and I summarize what we have discussed. So if you want to ask any doubts, you can ask. If you want me to summarize what I have discussed in this 12 weeks, I can summarize that as well. So today is I think 30th October. Next week I think it will be 7th if I'm not wrong. Maybe next Monday I think 7th, right? 9th is Wednesday, 8th, 7th. So 7th October we have week 11. 14th October we have week 12. So 16th October, which is Wednesday, if I'm not wrong, correct me if I'm wrong. So that Wednesday I'll be taking 1 hour session from 6 o'clock to 7 o'clock. So in that session, if you have any doubts from any week, you can ask, or I'll just summarize what we have discussed. So I'll go through the notes and problems that I have discussed. If you have any doubts, you can ask. So basically, it will be 1 hour and it will be very quick. We'll not have 2 hour long session. I'll be taking 1 hour session. So if you have any doubts in any week, you can ask. Or if you want me to summarize any week, that is also fine. But I will not be solving any problems because it is 1 hour. I would like to summarize all the concepts that we have discussed in the 12 weeks, or I can answer your query. Can I email you some of my doubts which I made mistakes? Can you help? Yeah, you can email any one of the TS, but don't send me like many questions because it will also be difficult for me to address. Or you can send the questions to all the TS, all the TS. So if you have say 6 dogs, then we can take up two each so that solving 6 questions in one session will take a lot of time. So we'll distribute among the TS. So it would be good if you send all the TS. Yeah. Okay, that is it. I think someone has drawn the line on the screen. If possible, please erase it. Okay, so now we'll move to our final problem. So I think we have solved how many problems? One, two, three. But in these three, there are many sub problems. So it is okay. I think someone has drawn the line. If possible, kindly erase it because I cannot erase it. Okay. So now we have solved three problems. Let us solve one problem, final problem. This is very simple. Instead of having RC, you have two capacitors. So I'm like you can solve this simple and also cost. So it is also similar kind of problem. Uh, I so 11 and 11 and 12 are same. 12, 13 and 14 are same. 15 and 16 are same. So all are same model. So if you see, all are similar model. So I'll solve one of this. Maybe I can solve this problem. So 13 problem I will solve. So this will be our question 4. So this is our fourth problem. Okay. So let us assume this is C1, this is C2. Okay. So this is plus minus VC1, this is plus minus VC2. I think we have around 20 minutes time. Let us see if I am able to solve. If I'm not able to solve, I'll give you the like idea of how to solve. Then you can solve the and do the math later. So now let us see the input current is I1. So here we have IC1, here we have IR1, here we have IC2, here we have IR2. So if I apply KCL, then I'll get something like this. I1 is equals to IC1 plus IR1, which is again equals to IC2 plus IR2. Okay. So IC1 is C1 into D C1 into dVC1 by dt plus IR1 is VC1 by R1 is equals to C2 into dVC2 by dt plus VC2 by R2. So is this clear? The simple equation I got from applying KCL. Or do you have any doubts? Very simple. Applied KCL and I got one equation. Any doubts until this point? Okay. So now I can also write Vs of t. So basically we are applying KVL. Please let me know if you have any queries. If you apply KVL, then I'll get Vs of t is equals to Vc1 of t plus Vc2 of t. So now I can write Vc1 because I need V naught, which is equals to Vc2, right? So I have to convert everything in terms of Vc2. So I'll substitute Vc1 of t as Vs of t minus Vc2 of t. Clear? So now this is the other equation that I got. Now substitute this in this expression. Any doubts? Or I can proceed further. Whoever is there in the meeting. Hello, any queries, anyone? Okay, I hope no queries. Okay, can we reduce the circuit, sir? No, actually, we cannot. One thing you can do is you can do R Thevenin and you can do V Thevenin. But anyway, for calculating V Thevenin, what will the circuit be reduced to? Again, there will be capacitor resistor, right? So let us not go in that way because that is not going to provide any benefit because it is time varying signal, right? Even if we remove this, then we'll have cos 10 to the power 60. And then again for calculating ZTH, uh, one is R, one is capacitor. So you'll get resistance in terms of resistance in parallel with the capacitance. So that will be very difficult at this point because sir has not taught the complex way. I mean, representing capacitor and resistor in terms of complex numbers. So let us not get into that aspect and let us solve in the conventional way because that is not going to help. But yes, if you can do that, that will be easy. But as far as this course is concerned, that will actually complicate things because not that concepts are not taught yet. So now if I substitute this, I'll get C1 into dVc1 by dt. So it is dVs by dt minus dVc2 by dt plus Vc1, which is Vs minus Vc2 by R1, which is equals to C2 into dVc2 by dt plus Vc2 by R2. So from here, if you write the differential equation, you will get something like this. You will get, I'll bring Vc2 onto one side. So we have C1 plus C2 into dVc2 by dt plus Vc2 into R1 plus R2 by R1 R2. You can simplify. I'm just skipping the steps. Is equals to C1 into dVs by dt plus Vs by R1. Clear? Just calculate it and check whether you are getting this expression. I hope it is clear. Do you have any queries? Clear. Okay. So now let us go back. C1 is 1 nano, C2 is 4 nano. We'll also write the value so that every time we need not go back. C1 is 1 nanofarad, C2 is 4 nanofarad. Similarly, we want R1 and R2. So R1 is 4 kilo, R2 is 1 kilo. So R2 is 4 kilo, R1 is 1 kilo. So let us just substitute and then see what happens. So we have C1 plus C2, 5 nanos into dVc2 by dt plus Vc2 into R1 plus R2, 5 by 4. So in the denominator, you will get 4K is equals to C1, which is 1 nano, 1 nano into dVs by dt plus Vs by R1 is 4K. Let us multiply by 4K on both the sides. And if you simplify, you will get something like this. So 20 micro into dVc2 by dt plus 5 Vc2 is equals to 4 micro into dVs by dt plus Vs. Agree? Everyone? Agree or do you have any queries? Hello. No. Okay. So now let us go. They have given VSS cos into 10 to the power 60 and VC2 is VP into cos 10 to the power 60 plus 5. So they have given the values. So let us just write. They have given Vs of t is cos 10 to the power 60 and Vc2 of t is Vp into cos 10 to the power 60 plus 5. Right? Let me just check if I'm not making mistake. Vs is cos 10 to the power 6. Forced response is Vp cos 10 to the power 60 plus 5. Okay. So now you substitute this in this expression and also this in this equation. So what we are going to get? We are going to get. So stay with me and see if I'm making any mistake. Also solve parallelly. So we have Vp into 10 to the power 6 into minus sine 10 to the power 60 plus 5 plus 5 VC2. So 5 VP cos 10 to the power 60 plus 5. And here we have 4 micro into 10 to the power 6 into minus sine 10 to the power 60 plus Vs, which is cos 10 to the power 60. Agree? Or did I make any mistake? Please let me know. I hope everything is fine. Yes. Okay. So now let us make micro gets cancelled with 10 to the power 6. Here also micro gets cancelled with 10 to the power 6. So now we are left with minus 20 VT sine 10 to the power 60 plus 5 plus 5 VT cos 10 to the power 60 plus 5 is equals to minus 4 sine 10 to the power 60 plus cos 10 to the power 60. Okay. So now we have to expand. That's the only way out. So we have minus 20 VB. Let me know if I'm making any mistake. 10 to the power 60 cos 5 minus 20 VB cos 10 to the power 60 sin 5 plus 5 VB cos 10 to the power 60 cos 5 minus 5 VB sin 10 to the power 60 sin 5. Now this is equals to, on the RHS side, we have minus 4 sine 10 to the power 60 plus cos 10 to the power 60. Okay. So now I'll have two equations. So one I'm writing sine 10 to the power t, sine, sorry, sine 10 to the power t, sine 10 to the power t. Other one is orange, cos 10 to the power t, cos 10 to the power t, cos 10 to the power t. So now we'll directly compare the coefficients on both the sides. So one equation that I'm getting is magenta, sine 10 to the power t. So minus 20 Vp cos 5, then minus 5 Vp sin 5 is equals to minus 4. And the second equation that I'm writing in orange, which is minus 20 Vp sin 5 minus, sorry, plus 5 Vp cos 5 is equals to 1. Agree? Or did I make any mistake? Please let me know. Is this okay? Yeah. So now, how to solve? Any idea or any want to? So first of all, we can make this plus because minus is there. Plus plus plus. Okay. Any idea or any thoughts how we can solve this? Anyone? Because we have two equations, two unknowns, and that two sine and cos. So anyone, any thoughts? There is a simple way which I'm going to explain, but before that, I'd like to see if you can come up with any idea. Anyone, any idea? Okay. So whenever we have something like this, we have to either try to cancel something or we have to convert them into sine square phi, cos square phi. So what I'm going to do is I'll multiply with this with sine phi, and I'm going to multiply with this with cos phi, and I'm going to add both of these equations. So if you see here, you'll have 20 Vp sine phi cos phi minus 20 Vp cos phi sine phi. So now once you add that, you will get 5 Vp into sine square phi plus cos square phi is equals to 4 sine phi plus cos phi. Agree? So now you will get Vp is equals to 4 by 5 sine phi plus 1 by 5 cos phi. Agree? What I have done? Everyone agree? Simple. I have just multiplied by sine phi cos phi and did some mathematical manipulation. Yes, sir. So now what we are going to do is, because we have one expression, this expression is there. So you substitute Vp in this expression. So what we will be getting is minus 20 Vp, right? So minus 20 times. So it will be minus 16 sine square 5 and minus 20. So minus 4 sine 5 cos 5. You please check if I'm making any mistake. I am skipping terms. Plus 4 sine 5 cos 5 plus cos square phi is equals to 1. So I have just substituted it. Now this will get cancelled. So cos square phi is 1 minus sine square phi. So I will write it as minus 16 sine square phi plus 1 minus sine square phi is equals to 1. So now can someone tell me what is the value of phi here? Basically, what I have done is Vp is 4 by 5 sine phi, right? You substitute this Vp here. So it will be minus 4 times minus 4 sine phi into this entire term. So minus 4, 16 sine square phi minus 4 sine phi cos phi. 5 Vp cos phi is 4 sine phi plus cos phi into cos phi. So 4 sine phi cos phi plus cos
The
square phi.
phi is 0.
So phi is 0. Yeah, very good. So phi is 0 degrees. So if phi is 0 degrees, what is the value of Vp? We substitute this in this expression. So what is the value of Vp that you will get?
1 by 5.
1 by 5. So I'll write it as 0.2. So I got 5, I got Vp. So let us go back to question and see what exactly they have asked. So in the question, they're asking what is Vp and what is phi. So Vp cos, so VC2 of t is what I got. So VC2 of t is equals to Vp, which is 0.2 into cos 10 to the power 60 plus 5, 0 degree. So this is the overall expression of VCP. So VP is zero point 0.2 and phi is 0 degree. So let us go and check whether it is matching or not. So VP in millivolts, we got 0 point 0.2, so it is 200 millivolt. So 200 and phi is 0. So if you see, I have not solved this problem, which is exactly the same, right? Nothing difference. So first you will get the, okay, let me just summarize quickly. So in this question, they have given some complicated circuit. So I have assumed this is VC1, VC2, IC1, IR1, IC2, IR2. First I have applied KCL and then substituted everything in terms of VC1 and VC2. I got one expression. Then I have applied KPL, KVL. Then I have converted VC1 in terms of VS and VC2. So I have substituted this. I got one differential equation in terms of VC2 and VS, which is what they have given in the question. So I have just substituted everything and I have solved for VP and phi. So I got VP and phi. Similarly, in this question also, you have to write VC2. Here there is no R2. So it is a simpler version. So you have VC1, VC2 and R1. So you have to write first differential equation by applying KCL and then by applying KVL and eliminate everything and write in terms of VC2 and VS. So now substitute this and solve for VP and phi. And this is the question we have just solved. Similarly, in this question, it is exactly the same as the question that we have solved. Only the input is 10 to the power 5t. and everything is same. If you see, both will get the same answer because nowhere uh, like uh, like there is, even though there is some gain, if you calculate and see, you will get the same. So basically what will change, here this expression remains same, here it will be cos 10 to the power 5, here it is also cos 10 to the power 5. So you substitute this in this expression and solve for vp and phi, you will get exactly the same. Vp is zero point 0.2 and phi is 0. I have solved, but you can also solve. All these are similar problems, so that's why I have solved one problem, and also we are running out of time. So, any queries in today's session? So, today we have discussed first order circuits with time varying inputs. So, if that input is some exponential, we have seen output will be combination of a scaled version of input plus a scaled version of the exponential decay term that we are getting from the natural response. We have seen the special case if the input is e to the power minus t by tau, then we have seen that it will be v1 plus v2 into t by tau whole into e to the power minus t by tau. We have seen if the input is cos omega t, output will be some k into cos omega t plus 5 plus that exponentially decaying term. Because it is linear, output will have the same frequency, but it will be a scaled version, plus there will be a phase because it's acting like a filter. There will be some phase difference. Apart from that, everything remains same. The points are same. You keep these four to five aspects in mind. First, write the generalized expression of capacitor voltage or inductor current. Then you apply the initial condition and get one equation. Then you substitute the solution in the differential equation and get another equation. Now solve these two equations to get all the unknowns. So once you get all the unknowns, then you got either the inductor current or the capacitor voltage. Now you check what voltage or what current they have asked in the question. Then you can use this inductor current expression or capacitor voltage expression to get the expression that they have asked. So this is very simple and straightforward. All the problems are similar. They can be solved by following these 4 to 5 steps exactly same way. There might be some resistor circuit, extra circuit may be a little bit different, input may be a little bit different, but all the questions can be solved using these 4 to 5 steps that I have mentioned. So if you have any queries, I can address, or we can wind this session up and we can meet again in the next week. Any questions, anyone? So this week is very simple, and I hope you will be able to solve. Keep these 4 to 5 aspects in mind. Solve as many problems as possible. Be confident. Don't make any mistakes. The biggest problem is either you will get 4 marks or you will get 0 marks. So don't be tense. Solve these steps. So any question, you try to follow the same step without making any mistake. You will definitely get the answer. So with that, we can wind this session. If you have no queries, don't have any queries, then we can wind this session. Any queries? Okay, then we'll meet again in the next week for week 11. And I wish you all the best for your assignment. And we are slowly approaching towards the exam. So please be prepared and please be thorough with all the concepts that we have learned. And I'll take one hour session before the exam where I'll clear all the doubts and I'll also summarize all the concepts that we have learned. Okay, with that, we'll end this session. Good night, everyone. Thank you for joining. And I wish you all the best. We'll meet in the next week. Okay, then bye. Good night.